This lesson focuses on Venn diagrams, drawing them, some definitions with intersections, unions, and complements. So the first thing I want to talk about is the definition of set notation. Set notation is a collection of numbers or objects. Every number or object in a set is called an element or a member of that set. The symbol U in a Venn diagram is called the universal set. It's like the whole group in the box. And then most subsets are labeled A, B's, and C's. So here's what a Venn diagram would look like. Consists of the universal set, so that's the entire box. Everything in that box, the universal set. Sets within the universal set are usually represented by circles. So you have a set A, which is an event, and then set B, things that fall in that would be in that circle. Venn diagrams show the relationship between two subsets or more subsets. Usually, we try not to get more than 3 subsets. Some more definitions, a complement. The complement of A is denoted by A prime. What that represents is things that are not in A. Not in A. Items that are not in A. So they're out in the universal set, but they're not in A. So this is an example of a complement. So we have the universal set, which are these 5 numbers, 2, 3, 5, 7, and 8. And then we have the elements in A, which are 2, 7, and 8. A prime, the complement, would be the numbers that fall outside of A. So that would be 3 and 5 are the 2 numbers that fall, and they would be outside as A prime. All right, some more definitions. Intersection. When you see this notation, A intersecting B, what you need to remember, it is both A and B. So as a picture, this would be where A and B overlap. And this is the notation we would use, A and B. The next word that we'll be introduced to is what we call the union. The notation looks like this. A union B, and what you need to know is A or B or both. A or B or both, and this is what the Venn diagram would look like. The next one is called disjoint or mutually exclusive. Disjoint sets do not have anything in common, so no items in common. So here are your 2 events, event A and event B. They do not overlap at all, nothing in common. So here's an example. We want you to write down the number of elements that fall in these sets. So the first set has 0, 3, 5, 8, and 14. This set has 1, 4, 5, 8, 11, and 13. Now let's see if any of these overlap. If we look at 8 and 8 overlap. So we need to erase these 2 and put them in as the overlap. Are there any other ones that overlap? Okay, see if you can find it. Notice 5 and 5 overlap. So I'm going to put 5 here. I'm going to erase this 5 and this 5. Look if any more overlap. All right, so now we're going to go ahead and answer the question. A intersect B. Is that region there? What are the elements in A intersecting B? They are 5 and 8. Now, A union B, A or B, or both. That would be all of these items. So you'd have 0, 1, 3, 4, 5, 8, 11, running out of room here, 13, and 14. Runs into both of them.